Hey there, welcome to dotnetFlix. So today we're going to learn about adding observability to our applications and in particular about OpenTelemetry, which is an open source standard that has come up in the last couple of years. And we are very glad to have Alex Thissen here on the show to teach us all about it. So Alex, first of all, welcome. What is
Thank you, guys.
OpenTelemetry and why should we even care about it, right?
Yeah, sure. So thanks, first of all, for having me on the .NET show. Yes, let's talk about Open Telemetry and in particular observability. I prepared some slides just to get us started and to talk about, you don't just do Open Telemetry just because you want to do Open Telemetry. There's another reason for it. So um, what we usually see is that if you start working and start developing, you pick up items from a backlog. You have a fast inner loop that where you can cycle quickly and try out new stuff, and then that all works fine on your machine. Then you go into the publishing your repository, and it goes into production. And that's usually where, well, what we notice is that in production, it's sort of we don't know what is happening there because it's production. So you can't really attach a debugger or in other shapes or form look into the system. So probably you recognize it, Edwin and Sander. What is it that you typically do to get more insights in your production environment?
Yeah, of course, adding log statements is something that
Yeah.
I see happening a lot so that you know
Mhm.
where the code is at a certain point in time. That's not always the best solution, but that could help sometimes. And yeah, when working in Azure, of course, you have things like application insights and tools like that to get information on what's going on within the code. So that's what I see used a lot in the projects that I see.
Yeah.
Yes, yes, and that's exactly the point, Jarvid. When we lead up to the point where we say, okay, this is where Open Telemetry really comes in, it's doing more than just logs because
Hmm.
logs have a place and they're useful, but they're not. Well, like you said, Edwin, not always the best solution. No, and it's kind of you want to do more to close a bigger loop, that gives you the feedback from the system, and it might be many things, right? But you want to gather some data from the instrumentation in your application, and that means that it's also called telemetry data because it's reading from a distance what is happening in your system, and then you would want to monitor that, and then finally you can based on the monitoring of your system, you can decide, okay, how are we doing? I know, do we get a lot of errors, or is this business feature even used? So you can get some real feedback, which what I believe is the real DevOps, right? You develop it, but you also operate it, and you need to know what is happening. Otherwise, you're steering in the blind,
Yeah.
and that means you need to do more. And logs are just part of the puzzle. But it's well, something that you need to do. So looking at it more of on an abstract way, to get more information, you need to put in some instrumentation. Otherwise, it doesn't come for free. You need to tell your system this is what's important. So you give it all these instrumentation, like the things are in your car that send out information on the mileage, the how many well the other things in the temperature in your car, for example. That's the instrumentation. You measure those things, then you observe them, so you collect all those things, you process them, maybe you filter them, and then finally you start monitoring them as well. So that's a kind of a process where you go from you need to put things in your application, the instrumentation, and that will send out the things. You need to look at it, and then you need to observe it and monitor it over time. So monitoring is more of a time series kind of thing, where you observe it at multiple moments and you see trends, you see averages, and all those things, and you can deduce certain things from that. Well, this is usually what your application does. It has instrumentation and it observes itself and sends it out. So it exports all the information. And then you have tooling, and you mentioned application insights, Edwin. That's one of the tools that's in the category of application performance monitoring that is able to deal with the information from your application. So that's good, but you can also, and we might get to talk about this, but you can also have the observing part done by what is called a collector. So something specific that is not inside your application, that does all the collecting and sending it to one or more tools. Now, this I think is where we get very close to why would you want to use OpenTelemetry? Well, it's this. The instrumentation is more than just logging, and people they have been trained since the beginning to put log statements everywhere, so they can sort of reverse engineer what might have happened. That's what logs are for, what happened, but it's meaningful things that you want to store over time, so that you want to read maybe a year later. If you want to know how things went, so we called from one service to another, and then yet another, and what happened where. That's more of following the flow of your application as a trace. So you're tracing the steps of the application, even in distributed scenarios. And logging is not tracing, and that's I think one of the most important things there, that people usually want to do tracing, but they use logging to do that. And that's where there's a big distinction, because they behave differently. And then the third one is metrics, which is about numerics, measuring things in numbers. So you can see how many errors did we get in the last hour, or how long does it take to process a certain request, or the things that you can put into numbers that you don't really want to read, but you want to see in graphs, for example. There's other things like health that tell more of what it's like on the inside, and auditing, which is logging from a security perspective. But we'll focus on the first three. And those first three are what they also call the pillars of observability. So logging, tracing, metrics are the three pillars, and they are important. And the good thing is that OpenTelemetry provides an open standard and a unified view of those three things. So that's where it's good. You don't need multiple things to do logging, tracing, metrics. You can use a single thing. And this is cross-platform. So there's many implementations on different platforms. It's an open standard, so you're not locked into a certain vendor. And there's, as a standard, that's also getting a lot of adoption by tool vendors, for example, that will adopt the OpenTelemetry standard. And that makes it a very safe choice. No lock-in, lots of flexibility, and a unified way of dealing with all this observability ways, logging, tracing, and metrics. It's part of the Cloud Native Compute Foundation, and it's the second most active project on CNCF. So only Kubernetes is more active. So there's a lot of people working on this and making this better.
So Alex, a question. So to get this completely clear, this is so OpenTelemetry is not a tool in itself, but it's a standard, right? And there's lots of tooling out there that adheres to this standard. Do I understand that correctly?
Yeah, that's correct, and it's one of the things that OpenTelemetry is. But I can show you.
Okay.
So this is what OpenTelemetry is as well. So we just talked about the standards, and I'll just put these things here. So the standard is, for example, the OpenTelemetry protocol, which is a wire format where information, the telemetry data, is sent out in a specific protocol type. If vendors adopt this protocol standard, you can connect your application. If it sends out OTLP through the protocol of OpenTelemetry, the tools can connect to it because they speak the protocol.
That makes sense. Yeah.
That's one thing.
Okay.
We talked about the signals. That's the term for OpenTelemetry to signify logs, metrics, and traces. And then you have both APIs and SDKs. So the APIs are the interface, what is it that we generate? And the SDKs give an implementation of how do you do that from your language, your platform. So there's a few logos there that give some indication. You can do this from .NET, but if you are in Java, Go, Python, Rust, you can do all of those as well.
Okay. Yeah.
So, it gives you the flexibility in a landscape where you might have many microservices, for example, implemented in different tool stacks, that you can still do OpenTelemetry from that part of your application and connect everything together.
Okay,
So flexibility all over.
cool.
All right, I'll give one slide, last example, and then we'll dive into code. But this is the kind of thing that OpenTelemetry helps doing, and it's important thing is the tracing. So let's imagine that we have a distributed system. You have a web application, and calls are made to the web application, but the web application itself is sending HTTP requests to an API service. So you have API calls. You might have a worker service where it's messages on a service bus, but you would want to know how do the things flow. And also, if you have even further calls, so an API service might call another API service, or might call dependencies such as a database, for example, or other types of storage. Then you would want to see how things are connected. So what makes this application, and how did it go, and where is a bottleneck, or where do errors occur, and does it escalate up? So giving you insights by being able to trace the flow of this application from the very moment a call comes in to everything that happens afterwards. All right, so I have this demo application here. It's a simplistic application. It is a front end with a web application. It's in .NET 8, so it's fairly recent, also with all the libraries that are used. And then there's a web API. That's the back end for the web app. And the calls are made from the Razor pages in the front end to the web API in the back. And so it's not a single page application, but it's a server-side application. Both of these are fairly standard ASP.NET Core applications, and they're all connected together with a Docker Compose that uses these two in a container to spin them up and to connect them. And once you start running, so let's start the Docker composition, and I'll show more of the composition in a moment. But essentially, the Docker Compose starts the web API and the gaming web app, and a lot more, but we'll get to that. All right, so we'll wait for the. So we have here the web API in the backend. The web API is functioning, so we can see what happens. Get some data from it. And you see that there's at the moment 3 high scores, because this web application is about retro gaming. I'm wearing the shirt, Atari gaming, just for Christmas time, and also to be in theme. This is what the backend provides. It provides a way to get high scores for old video games, and you can also get individual scores per game or post new high scores. And the front end. The front end will show the high score, so we will call into the web API and give those exact 3 high scores that we just saw, but then in this way. So, and we can play around with it. So we can say limit is 2, and we should get 2, and we can say limit is 0, which doesn't really make sense, but we can also say limit is 1. Now something weird is happening. Well, this is intentional, right?
Oh, one is an edge case.
1 is the edge case, not the 0. Yeah, well, but just to make it a little less obvious. But there's obvious a deliberate flaw in here. But something is happening, but it doesn't show a single score. But it did take a long while. And now the question is, if this was production, how do we know what is going on? Well, we did a couple of things, right? Because we needed to do the instrumentation. Now, you could do logging, but what I'll show you is the things that were done that will allow you to get much richer information. Maybe I should show that first. So we have a few additional things running in the Docker composition. And one of them is this Jaeger. And Jaeger is a tracing tool that can show collected trace information. And it has a couple of ports. So we can take this port 16686. We can open that, localhost. and it shows us this Jaeger user interface that is already collecting all the telemetry information. So let me see if there's something here. So we can say, okay, show us stuff from the gaming service and find the traces there. And as you can see now, there's things here, right? So we can see, okay, let's take this one. This is a successful call, the one that we did initially that showed the 3 scores and everything was fine. It might have been the one with 2 scores. Let's see. But this shows what is happening. So we get calls starting here on the web app that get delegated to this thing called get high score. So we're doing something here for getting the high scores. And then we do a get from the web application to the web API. And we see that we transition from green to yellow, which is a call to a different thing in this distributed application. So this is a network hop that is happening here, but still we see the combined information of this distributed trace. Yeah. If we want to see more, we can see, there's things like this was in the region West Europe, and it was the leaderboard web API, and the namespace was .NetFlix. So we have all this rich information. Apparently, it was this thing, and it was collected with OpenTelemetry. Many things and tags that help us investigate, what is going on. We have the query information. Now, this goes all the way down. Let me just collapse this a little bit, all the way down into the database. So you can even see the database query that was done. So pretty rich information that you get from your system. And now the question is, how much work did we have to do? Well, enter OpenTelemetry, because you can do this in multiple ways, and there's all these commercial tools that help you here. It might be Datadog, for example, or Application Insights, Raygun. There's a lot of those. Now, in our case, we did the following. So in our pages, we would go to the index page, was the home page, and we go there, and then we see, okay, so what do we do? On the get async, that's when we retrieve the home page. We have this limit that we saw, and it's if you don't specify it, it's set to 10. Now, one of the things that you start doing is thinking in terms of activities. So we say, okay, when we do this, we kind of start a special activity that's about this get high scores. We saw that in the information later on, right? So we can isolate certain units of work that we want to capture and have a start and an end. That's essentially what an activity is in Open Telemetry speak. It's called a trace or a span. So it spans something in time. And then we start doing work. And one of the important things is, well, there is the traditional log here, right? So log information still works, and you can do that. But what you see here is that instead of doing logging, you can also think in terms of events. What are the events happening during this activity? And this is where you can add things that pretty much resemble logging. And this one does it pretty basic, right? It just gives a name that says activity events called high scores retrieved. You can be much more explicit in all the things that you want to emit. So let's look for another one. Give me a second.
And these events that you emit, Alex, they show up in your trace?
Yes. So we'll circle back to how this pops up, but the more elaborate one, instead of just doing new with just a description like you would do a log message, you can add all these specific tags that give a key value pair of, for example, gamer nickname with a name. So we are emitting these things as well. So just to go back to what you also asked, do we see those? So this was in the get high scores. This is the high scores retrieve. That was the simple one that we just saw, right? Yeah. So you can see those things popping up here. But also, if we go back to the search, we can say, okay, now this tag. So what this is, Not sure if this one is here, so let's have a look. No results yet, but we can do something like post a high score and say Alex 360. They do a game. I'm not sure which one we can do. Let's say Dig Dug. And we say the score is 42. Execute it. Let's see if it's successful. Yes, it is. And in here we might just find traces again. Let's hope this works. Not yet. It's in the web API service, so that might help. See? Okay, so now we see that there's two things here. This is one that's a bit older, I think. That's earlier today when I did some preparation. But this is the one we just did, where we did a post. We posted a score. That was another activity, and we had three SQL statements that were part of, retrieving the current score, see if it's higher, and then doing a write or an update on the scores. So this is where you can find it. And the thing, I think it might just be here. Let me see. No, not this one apparently. So we'll try the next one. So we'll go to this one here and do the tags here. This is another thing that's the score nickname. But if you look at the logs, we had this gamer found and a gamer nickname. So we found this thing because somewhere in this entire trace there was an event. It appears on the log, so that's kind of confusing maybe. But these were the events in the activity that had rich metadata. Stating, okay, this is the thing about the gamer. It has a nickname, and this is the thing, and then you can query for that. So if it's numeric, you can do comparisons. In this case, it's a textual search, so you can find things like maybe error numbers that were reported by to the help desk, where you can just search through your things based on those, and you don't need any textual searches in your log messages or regular expressions or whatsoever, because this is actual metadata that is queried in the right way. These are tags to things that appear. Now, different toolings, they have different names. Some call them events, some call them logs. Read it for what it is.
And the cool thing is that you can choose more functional type of events or metrics, right? Because based on the domain that you're in, certain information is important when you're looking through these logs. And that's the cool thing, that you can really easily add those tags, and then you know what actually is going on and for which gamer in this case, or for which customer, or for which contract. So that's pretty powerful to have that in your information here.
Yeah, because in this case it's score of 4242. You see that's also logged in the metadata.
Yeah.
So we'll go off script anyway, but you could say something like score bigger than 4,000. I'm not sure if that would really work. No things found. So I'm not sure if this would really work in this Jaeger UI tool. But these are the kind of things that you would want to do, right?
Yeah.
The queries on the information that is in your logs. Now, other things like application insights can definitely do these kinds of queries, but this is pretty powerful to do. Now, I might just try to find one other thing. So if we go here and we go to the full traces again, let's get rid of this, otherwise we won't see anything. So this is, for example, is the thing where it went wrong, right? With the limit is 1, all of a sudden we saw nothing. And what you can see here is how Polly does a retry for 3 times. So that there's the initial call that failed because it timed out. So it was Polly doing a timeout if it takes longer than 1.5 seconds, which you can see here. It does it terminates it, but so there's this 5-second delay that was built in. That's longer than the 1.5 second that Polly is willing to wait. So it terminates the call and says, okay, now let's do the retry policy 3 times. 1, 2, 3 times retries. And they all fail because they take 5 seconds, too long. This might happen in your system, and this is how you would deal with unresponsive backends, for example. You would retry a number of times, but not wait for too long. Otherwise, you would have to wait 3 to 4 times, 5 seconds or 20 seconds, which is way too long. You can see that these things are also indicated with an arrow where it says, we are error true, so things did not end well. So this activity failed, which gives you this rich information on what happened with what activity. And since it's composition of many activities, you can see what is happening. Now let me try and find, this one, container.id. So there's this information on containers that says this is a very long instance ID as we are running this in a Docker Compose composition. Now, the way that you can set this up is in your programs here. So here we see the timeout that we do with a retry 3 times, and we also do some recording of those exceptions. And we say if this happens, so if we do need to do retry, we're setting the thing that happened as an error. So that's where the red icons come in, where you can see, okay, this is what went wrong. You can even see the retry count for the umpteenth time of retrying. Now, the important part here is that in your bootstrapping of your application, you will say, okay, so we'll add some services that are related to OpenTelemetry. And these are the ones related to tracing. Remember, tracing, metrics, and logging. This is the part for tracing. And we're telling it, okay, so there's this source of activities, where we just created a static that has a certain name, so we can quickly look into this. So it's just a static activity source with a name. That's gaming web app. The next thing that we do is we tell it, okay, we want to add some information about this part of the application, so this resource. And if you go back up, you can see that you're saying, okay, I want to create a default resource which does the things that we saw with .NET OpenTelemetry, the 1.7. There was the information about the library that we've used. That's populated by default in this if you start with this. You can also do an empty resource builder and start with something completely blank, but this is usually what they do. So you can see where does this come from. And then you'll tell it, okay, this thing is about a service, and the service is called the gaming web app. It's in this namespace dotnetFlix. And this is its version, and you can be, you do your own type of versioning. It's just textual. The service instance ID is this one. So it might be different from the name, but this is a static thing. So when we run multiple things of these, they are all collected together. You could also keep them apart by creating new IDs for every instance, but then you would see them behave individually. And now we're just aggregating everything together, even though this might be an application that is replicated many times in a Kubernetes cluster, for example. You can add additional things. So we saw this region, West Europe. That's what we said. You can say this is a particular production environment. This is, you can add your own metadata that is added to everything that you do from this resource. So in this case, it's the tracing, and this will be added to every output of trace. And you can do detectors as well. So the container ID comes from this container resource detector. But there's many detectors out there that are also related to your Kubernetes cluster. And well, there's a huge list of things that you can just add, and it will detect based on the environment it's running. And it will add additional metadata as well. Then there's this new thing in .NET 8, which is, I think, kind of cool, where you can say, okay, I have some ambient metadata that you can put in your logs or in your settings. Let's see if it's, I think it might be here. No, it's not. So I guess I'm not setting that here. But you can say, okay, I want to use 4 types of information from the ambient metadata. That's the environment name, the application name. Those are added automatically. And then you have the build version that you can set through config or programmatically, and the deployment ring. So you can say this is maybe the alpha ring, or this is non-production. It can be related to your environment. If you do ringed deployments, then this might indicate, do we want to show that if we enrich the service log, so all output from OpenTelemetry. Well, some other things, because the bootstrapping is pretty short, you can say, okay, if we use HTTP clients, add instrumentation for that as well. And the effect of this will be that on using HTTP client outwards, it will add W3C distributed trace information to the headers of the outgoing call. On incoming calls, you need to do this as well. So if you're on the API side, you can say, I had HTTP client instrumentation, and you will digest those headers and say, so this came from this part of the application, and now we're continuing the overall bigger trace that has started at some root, and we add more things that happened along the way. So we continue the flow of the application by piggybacking on who called us. Okay, let's just be part of that, but be a child's activity of that, because we're just part of a bigger thing. You can do ASP.NET Core instrumentation, which also will output memory pressure, garbage collection rates and those kind of things. That comes from this one. And then we needed to do the exporting. In this case, we are doing some form of exporting from our application to console, and in this case also in the OTLP wire format. So we're outputting it to some sources that are OTLP. And well, if you look at the API side, is kind of similar, because we have, again, the resource builder, except now obviously we have the web API service. And maybe here we can find the settings for the ambient metadata. See, so the build version and the deployment ring you can set in config. The other two are read from the hosting environment. So the running directory, so your application name, and the environment is your the environment as you know it, that you can set in the program CS as well. Now, the fact that we got all this the SQL statement is because we said, okay, instrumented for EF core, and that will happen as well. Now, the effect of these things, if you put everything together, is that you can collect it in something like Jaeger, and view the combined things from the front end and the back end. And this is where you can see what type of format are we using, but it's W3C distributed trace format. That's the thing that we're using. All right, so the next thing is about the metrics. And the metrics give you some insights in how fast things are going, what high scores are being scored. And the idea is that you create a meter, which the meter is the thing that's being measured. And from a meter, you will create counters or other things. Let's just quickly get some slides there, because that deserves some explanation. So the measurements that you do from instruments. The instruments come from a meter, and the meter is created through a meter provider. Now, the good thing here is that this flow, you start from left to right. So you start with a meter provider, you create meters that create some instruments. Instruments can be counters, which are things that increase or decrease all the time. So it's like the number of visitors, that the number of daily visits, that's an only increasing number. Never lose visitors. The active users might go up and down, so that's where you do the up down counter. You might have a histogram, where you say, okay, we want to have buckets of how long does a web request take, for example. You say, okay, from 0 to 100 milliseconds, 100 to 500 milliseconds, 500 to 1,000, and above. So that's the histogram, and you can put each request into those buckets, and you can create like a bar diagram from that as well. And a gauge is more of a type of instrument that might be best visualized with a graph that goes, every which way, up and down, like the temperature over day. There's no counting. It's an active measurement, and it will vary over time. Now, that's important to remember for the instruments. They come from the thing you measure. That's the meter, and they can have multiple instruments. So you can measure many things from an engine, for example. It's not just the temperature. It might be oil pressure. It might be different things. All right. Now, what's cool about OpenTelemetry is, and the implementation for .NET is that they are leveraging things that are already in .NET. So when we saw the activities and the add event and those kind of things, that's built into the .NET framework. So you don't have to rely on anything OpenTelemetry. The bootstrapping part, that's OpenTelemetry. So that's where you're saying, okay, if we have activities, which is pure .NET, we are using OpenTelemetry to listen to activities. That's what you need to do. And in this case, for instruments, you instrument with .NET. So you use meters, instruments, and measurements from .NET. You see the various NuGet packages that you will need to add to your project, but it's all baked into .NET. And the meter provider is a way of creating meters that have enough metadata, for example, to be useful and informational enough. And you can see the things that are needed for that. So we have things that hook it into the hosting. We have instrumentation specific things and exporters, where exporters allow you to export it to different destinations. Excuse me. Yes. So in .NET, it's using generics for instrument of T, measurement of T, and then you can start instrumenting your application again. So for example, here we have the high score meter. You give it a name, so it's this high score thing in a so there's a naming convention which uses dot to signify, this is where it comes from and this is what it's about. It's a counter of integers. And you have some convenience methods that will help you use this counter in the right way. So if you say high score retrieve, we want to count the number of times that high scores is retrieved. So we just say, okay, so in this counter, add 1. And you'll see this alphas operator in more places, because it could just be that this thing will not be created, because if there's no active listening to a meter, counters will not be actually created, because that's just over. No one is listening anyway. It's the same for activities. It's the same here. So it does mean that you need to do the bootstrapping, where you say, okay, so we have the OpenTelemetry, we had the with tracing, this is the with metrics, but now you're saying, okay, add this meter. So we have the high score meter here. If we don't add this thing, it will not be created. So it will not actually do anything. You get a null reference exception. So that's why we use the alphas operator. You see the same things, right? So we have this health check meter. Source code is available, so you can check how we implemented this health check meter. It's our own extension. And then we have the resource builder that we saw before. So what we added here with the resource builder, remember that's the thing here where we just add all this metadata that is added to each and every outing of OpenTelemetry information. We're using the same one for metrics as well. So it kind of unifies tracing and metrics, so you can see which metrics did we have during which traces. Putting everything together and just saying, okay, just give me information about metrics in West Europe, for example. And you will, again, could leverage this metadata to find the things that you're looking for. Exporters, you can have 0, 1 or more. 0 wouldn't really make sense, but in this case, it's console and OTLP. You see a pattern here, right? So by using this, we're not relying on anything that is specific to OpenTelemetry. Well, it is OpenTelemetry, but not any particular product. This is just a standard. Logging. Logging is the way it's set up. It's a logging provider, but we're using OpenTelemetry again with the resource builder and with exporters. So it's these things are kind of common in logging, how you configure logging, and this is the exporters and how you configure how a thing is exported and to which endpoints. You can see that we're exporting to Seek here, which is the local thing. And we're using this HTTP protobuf for communication with it. But Seek is, as you can see here, a OTLP compliant logging provider, because it can accept this OTLP format and store these things. So you will get something like this. So we have Seek. We can go to this port here. And then you can see that everything that was logged is here as well. So let's take this timeout occurred. And what you see is that there's this container ID. You have the service namespace that we saw before. We have the telemetry information from the create default. And we have a trace identifier that puts this into the bigger distributed trace. So we can even see which things were logged when. And that's why we see all this combined information. Here we just see logging. In Jaeger, we just see the tracing information. But if you go to something that can combine it all, that would be something like App Insights. So let's go to I see that I have it here. So it already created an application map from all the information that we had. So we can see here is the dotnetFlix. We have this one instance, 10 calls were made. If we zoom in a little bit, you can see that some of them failed. So we can start investigating and say, okay, 2 things failed. So what happened there? Let's see these failures. You will get some information here on what happened, how, and when. So this will take a bit of time to load, apparently. Let's give it a few seconds. But this will give you some insights on what is happening. And this is the application insights in this case. You might have Datadog or other things where now you can see, all right, so some things went wrong, right? We see the information of activities, so the get originally, and then the get high scores, but apparently we didn't go much beyond that. I hope that we get some additional things here. So it's trickling in now. So there's 5 samples. This is what it says, okay, you should maybe look into this one. So it's suggested, let's follow that one. And then we get end-to-end tracing details. And this is what you might recognize from Jaeger. It's kind of the same information, right? So we have the retries that we see here, the 3 retries, and similar information. But if we go now to, let's say, get high scores and see what is happening there, you see all this additional information, but you can even see all the things that happened there. And where the one thing in Jaeger, we saw that things were called log. Here it's called trace. So things that we said with retrieving high score with a limit of 1, that's actually using semantic logging. But it's a log message, but it appears as a trace as part of the things that were happening. So we had an incoming request on the front-end web application. We had this internal get high scores because this was a unit of work that we started. And as part of that, we did some logging here, and we did an HTTP request. We got to this dependency, that's the web API, that had this incoming get request. And then internally there, we did get scores, and then things went wrong. And this was again at the front. This is just a time line that you see. It doesn't really say where things happen, but if you want to see that, then you can see this, right? So what happened where? And if we take, for example, this trace thing here, you can see that the limit is 1, for example. So this is where you have semantic logging, where these things like limits, that's in this message as well, limit of 1, that is actually listed here. I'm hoping that I'm pointing at the right one. I think so. And that allows you to do some queries as well. Let's see if we can do that. So if we go to the logs, I always need to remember how this is exactly done. Let me think. Custom, might be custom events, where limits equals 1. Let's see if this works. I think not so much.
You may need to escape limits because it's also a keyword in
yes.
Gusto.
Yes. So let's not do this because you need to be more proficient in.
It will be homework for the viewer.
Yes, exactly. Find out how you can do this. It might just be wait up. No, we got this thing here. It might just be traces. And it's where? Yeah, now we're getting closer. And then it's something like, we'll give it the living on the edge. Is it custom dimensions, limits? equals 1. No, oh, it might, but does it work? Will it work? Unknown functions. No, let's, but it's something like this, right? So you can query that. So sorry for that. Let's see, what else? Yeah, you can also look, no, not at the live metrics. You can look at the metrics. And the metrics is where, and this takes a bit of time, but if you add those metrics, like the high score, for example, you get this custom thing that says application insights metrics. And then you can see all the metrics. So the high score count, for example, you can see that we did one of those, right? But this will be an increasing number. It might just be the score, for example, might be interesting. So we had this 4242. This is the score. If you would have done more, you would have seen this fluctuate over time. So that's the metrics coming in as well. So this is an average. You can do counts and those kind of things. So you can pick whatever you want, and you can do the Kusto queries to create bigger, better, fancier graphs that show exactly what it is you want to look at.
Yeah. Really nice, Alex. It's really powerful having all that information at your fingertips. One thing I was wondering about, so how do you prevent shipping like gigabytes of telemetry data? Because it could obviously also be a performance impact.
Oh yes, definitely. Well, I think that goes back to the what you do per environment. So you would need to make sure that you um, look at what you want to do where, and what you want to collect, and what you want to let slip by. So I'll show you one last thing, and then we'll wrap up because there's so much more to be told. In this case, we saw things in Azure Monitor, right? So that's application insights as a view on Azure Monitor.
Yeah.
But we also had all these OTLP exporter things, right? So we were outputting this to Seek in this case, but the other ones just said OTLP exporter. And where did it end up? Well, it ended up at the default OTLP exporter endpoint. And what was running there was another container, which is this OpenTelemetry container, which is a community contributed implementation of a generic thing that has all these things that it can collect. So this inputs and these exporters on the other side. And the cool thing is that you can just configure that with receivers. That's the receiving side. And we're telling it, okay, we're receiving things OTLP style with gRPC and HTTP. If you have an older application that's, for example, doing Prometheus metrics, you can say, and also we have a receiver that's Prometheus. So this collector can collect many different formats, amongst which is OTLP. Then it says, okay, we want to output this in different to different exporters, and we give some details about it. So we can output to Jaeger, for example, but also to Seek. So this is also sending it to Seek. So through this exporter, it's also sending to Seek. And this is where Azure Monitor is being output. Don't worry, I'll get rid of the Azure resource later on. But this is how you would configure Azure Monitor, and it can send it collected and combined to Azure Monitor. Now, in a picture, that would look something like this. Let me. This is what you might have if you with what we've seen so far, right? So we saw Jaeger, for example. We saw Seek. There's also Prometheus being output, but this is for a local development setup, which is great. But you would have to add all these things specifically that says output it to Zipkin or Jaeger, output it to Seek, and you didn't see that in the code. You never saw Prometheus and so on. But still, we could make it end up there because Seek was OTLP compliant, Jaeger was as well, and Prometheus, you would need to do something specific. But instead, we combined everything. So we just said do OTLP all over the place. And then you can combine it and send it to tooling that can work with that. Now, to your question, Sander, that this is what you can do, and everything gets sent there, and then you end up maybe with gigabytes of things, and that will be expensive because these tools, you need to pay for consumption, and more data, more signals is more money for them and cost for you. Now, we'll skip this. There's the good news if you do Azure, but in this case, I wanted to demonstrate that a collector can be a sort of a protocol transition thing, because if you have applications that are implemented using Zipkin, you don't have to rebuild that to use OpenTelemetry. you can use the collector, the OpenTelemetry collector, to collect Zipkin and OpenTelemetry and Prometheus, and well, there's a bunch of them. There's a good dozen of these receivers for the collector. And with the configuration, you can say, okay, for our testing environment, we send out a lot, but we'll send it to something like this, our development or our testing setup. And that's a configuration file that says, okay, we do OpenTelemetry for Jaeger and Seek. Prometheus goes to Prometheus. And then we can do Grafana or something at the other end. Doesn't cost anything. You can run it from containers on your development laptop or in a virtualized testing environment that you spin up and destroy after testing. But if you change the configuration, then you can say, okay, let's do some format. In this case, we did OpenTelemetry for all 3 signals, and we're sending that to Azure Monitor. That's what we just demonstrated. And that's where you can see that you can get this unified thing of logs, traces, metrics. If you have new applications, it would be beneficial to do OpenTelemetry because you can add all the metadata. You can be very explicit. Your application only relies on .NET because it was the .NET meters and instruments, the activity sources, and the standard logging. But you, in your bootstrapping, you tell it, okay, but add these OpenTelemetry things. So there's a single place where you can find the OpenTelemetry specifics. But it gives you all this flexibility because you can use the collector or not. In the collector, you can send it out in a format which might be this or this, whatever you put in the configuration file. And that's where we kind of started off at the beginning, I believe, which was here, where we had this application with a separate collector that did all the harvesting and processing, but also filtering, enriching, redacting, so getting rid of accidental secrets that might be in there. So you can do a lot of things here, anonymizing before it's being sent forward, and it doesn't have to be part of your application. And this OpenTelemetry collector is open source. It is very rich. If you would like something yourself, there's a starter that you can say, okay, this is the bare bones OpenTelemetry collector, and I'm adding my own things in there that is specific to my use case. But all in all, I think OpenTelemetry, because it has such traction, because it relies on .NET things that are already there, only adds the bootstrapping and the harvesting of the telemetry data. It gives you all this flexibility to do observability in a much cleaner way. Let me see. Yes. So that's kind of how you could close the loop, observe your systems in a better way, leverage this huge traction that OpenTelemetry has, and then still be able to pick your own tooling that gives you a real DevOps experience for everyone to move from development to production in a nice and clean way.
Pretty cool, Alex. It was a great overview of the OpenTelemetry standard and the tooling. And you showed a lot of .NET stuff, but what I also really like, and I have seen this actually in a production situation once, is that because you have these libraries and SDKs for all the different programming languages, also if you have a kind of a hybrid setup in your company, so you have some microservices in Java, some microservices in .NET, there are actually companies that have that, or they bought a system that was built in a different technology. You can also leverage this stuff, and you can still have end-to-end tracing throughout your entire system. And I think that's really powerful. And of course, that's also where the power of a standard comes from. So I think this is a very great step that we are doing right now, because observability is one of the most important things in a distributed system, I think.
Yeah, definitely. Yeah, you nailed it by saying that the samples are in .NET, so you can use it there. But even if you have different tool stacks or frameworks and platforms, many of them are supported, and I think the support is growing. So you can still combine it in a heterogeneous landscape, and that makes it like a really good choice, vendor agnostic. So you're not locked into anything, and even if you are using vendor specific tooling, make sure that it's OpenTelemetry compliant or compatible, and then you can even combine it from there with the collectors that we just saw, because that might be the collector for your particular application, right? And then feed it into your whatever application performance monitoring tool you have.
Yeah, definitely. So thanks for showing that. It was a real comprehensive overview. So I think there's lots of great information in there. Everyone at home watching, I hope you like this episode. If you like us, please subscribe to the YouTube channel. And then we'll see you at the next episode. See you later. Bye-bye.
Bye.
Bye-bye.